everyone. How are you guys doing today? Good. Today's day is 7/7/25. We have 7/7. I like to see my dates. Sometimes it makes me like, oh, it's so cool. Like 2/4/25 or 3/4/5. Like the dates, sometimes the dates makes my day brighter. Okay, anyway. So we are done in chapter 6, entire chapter 6. From 6.1 to 6.7, we did everything. Today and tomorrow we are going to do chapter 7. Tomorrow we are going to decide our exam will be up to what? 7 point, which section? Okay, but I already posted the review sheet on Brightspace. If you haven't noticed, go to Brightspace and the table of content, you see review sheet, and in the first review sheet you see the exam 3 review sheet. Our exam will be this week, Thursday. The homework was, we had 6.1 to 6.5 due tonight midnight. I forgot to assign them. I told them in class, but I forgot to assign. So as a result, I'm going to assign everything next Monday. So if you haven't done them by tonight midnight, no problem. You can definitely done them by next week Monday. So chapter 6, entire chapter 6, and from 7.1 to some sections. I don't know how many sections. Probably 7.1 to 7.4, I think. All of them will be there, will have their due date next week, Monday midnight. So I'm going to assign them today. I forget to log in my MATLAB. Okay, any question before we start? Any question, comments, concern, complaint? Nothing? Do you remember your factoring? When you have two terms, how many ways you can factor? What are they? Two terms. When you have two terms, how do you factor them? One of them is GCF. What's the other method? Difference of perfect squares. When we have four terms, how many ways you can factor them? Good, GCF and grouping. So two terms and four terms, they have only two choices, either GCF and or the other method. And for three terms, there are so many ways we can factor three terms, right? What is one of them? AC method. What's another one? Trial and guess method. What's another one? GCF. And what's another one? Direct factoring. Like why you just factor directly. You don't have to do anything else. So GCF, direct factoring, AC method, trial method. And for AC method, you have two of them, regular AC method or weird AC method. Okay, chapter 7 is a little bit different than chapter 6. In chapter 7, we are talking about rational. Rational means we have a fraction. So instead of having a number on the numerator and a number on the denominator, we have an expression on the numerator, an expression on the denominator. That expression could be polynomial, could be a line, could be anything. Not only number, okay? It has a variable and or numbers. And for rational, our denominator cannot be 0. That's the only problem we always have to remember. Whatever you have, the denominator can never be 0. So first we are starting with evaluating rational expressions, which is same as what we did for functions. All you have to do is replace the given numbers for x, all the x you see, and then simplify. So this is something easy. It will be in your homework and also in your quiz. So for rational, we're going to do many things. First, we're going to do evaluation, how to evaluate rational. And then we're going to find the domain of the rational. Then we are going to do addition, subtraction, multiplication, division of the rational. And then we are going to do real life application of rational and solving rational equation. So chapter 7 has many sections like chapter 6. We are going to do them one by one. First thing is easy. We have f of x is that. And we want to find out the first thing is f of -1. It means all the x you see in the function, just replace them with -1 and then simplify. So we have -1 plus 12 and -1 minus 1. And then you do the math. What is -1 plus 12? 11. What is -1 minus 1? -2. Can you divide 11 by 2 evenly? So you can stop. If you can divide evenly, you have to divide that. If you cannot divide, just leave it. But if it's simplifiable, like let's say it was 10 over 2 or anything else, you have to simplify. The next one is finding f of 0. So you have 0 plus 12 and 0 minus 1. What's 0 plus 12? 12 and 0 minus 1? -1. And I cannot leave that alone because you can simplify. So how do you rewrite this? -12. Anytime you have something to simplify or rewrite, you have to do that. And now comes the interesting one. F of 1. So we have 1 plus 12 and 1 minus 1. What is 1 plus 12? 13. 1 minus 1? 0. And now what is this? You have 13 candies, and I'm telling you to divide all the 13 candies into 0 pieces. Can you do that? So what's the answer? It doesn't exist. It's not possible. You cannot divide anything into 0 pieces. It's simply impossible. Let's do one more. It's not given here, but let's do it anyway. F of -12. So we have -12 plus 12, -12 minus 1. What is -12 plus 12? 0. And -12 minus 1? -13. Now what's the answer? 0. You have 0, it means you have nothing. And I'm telling you to divide your nothing into 13 pieces. What do you have? Still nothing, right? Because you started with nothing. So the main idea, when 0 is on the numerator, it exists. The answer is 0. But when 0 is on the denominator, we cannot divide anything into 0 pieces, so it becomes undefined. It doesn't exist. Okay? And that tells us what's the domain of any rational. Denominator cannot be 0. So whatever expression you have, to find the domain, we have to exclude the numbers, what makes the denominator 0. The number or numbers. Whatever makes the denominator 0, we have to get rid of them from the number line. And everything else will be in our domain. But any question on this one before we move on to the domain? Great. So for rational, all you have to do is remember one thing. denominator cannot be 0. And then from there, you're going to solve for x using factoring or any other methods. But the main idea is the denominator. We don't care about the numerator. What do the numerator? We simply ignore. We only look at the denominator. So our denominator cannot be 0. Now this is what we have on the denominator. That means this expression cannot be 0. So we take x cubed plus 7x squared plus 6x. And we said, well, whatever we have here, that cannot be 0. From there, our goal is to solve for x. Because we want to see which x values makes this expression 0. They cannot be in the domain. Now, how many terms we have? How many terms we have here? 3 terms. How do you solve 3 terms? We can use easy method, but before that, what do you observe? GCF. So what is our GCF here? X. After I factor out GCF, what remains? X squared, then 7x, 6. And now, can you factor this? Can you think of 2 numbers multiplied to 6 combined to 7? 6 and 1, definitely. 6 and 1. How about their signs? 6 definitely has to have which sign? Positive, because the middle sign is positive here. So the bigger factor always have to have the middle sign. And now from 6, if you want to get 7, are you going to add 1 or subtract 1? So we factored our trinomial using GCF and direct factoring. Eliza. How did you go that on? We have 3 terms, right? What do you observe in all 3 terms? X. So you have to take out this GCF. So you only factor this x out. So we factor already a factor, right? So you need to bring your factor down, and then you need to factor this more. So can you have 2 numbers multiply to 6 combined to 7? I'm not using any method, I'm using direct factoring because our x squared is 1. So I have the 1 in the front. So the denominator gives us 3 factors. None of them can be 0. So the first factor cannot be 0. The second factor also cannot be 0. The third factor also cannot be 0. If one of them is 0, their product is 0. But when one, the product is 0, it is the denominator. Denominator cannot be 0. And then you solve for x. Fortunately, this is already solved. It has nothing to solve for. From here, what do you get? X cannot be which number? -6. And from here, x cannot be which number? -1. In other words, from the number line, we can substitute x, all those x, with any number except 3. 0, -6, and -1. We cannot use these from the number line. So our number line has -infinity, smallest number, +infinity, the largest number. You can take any number from the number line, plug it here, except 3 numbers. What's the first number? The smallest one. -6 is the smallest one. And then what's the next number? and then we have 0. So only these three numbers we cannot plug in, but we can plug in everything else. So can you plug in anything from -infinity to -6? So domain in interval notation is -infinity to -6. And we are going to have parentheses because we cannot use -6. Parentheses means can't use the number next to the parentheses. We cannot use the number next to the parentheses. That's why we use the parentheses. So who would like to give me the next interval? -6 to -1, which is here. How about the next interval? Perfect. -1 to 0. And how about the last interval? 0 to infinity. In other words, we are allowed to take any number from the number line except these three. Now, in your homework, they want you to write, so this is interval notation. Interval notation. There is another notation, we call them set builder notation. The set builder notation says, well, our domain is the set of all the x values so that x is a real number and x cannot be -6, -1, 0. So on my MATLAB, they wanted to write in set builder notation. But in the exam, I'm going to stick to the interval notation. So they will give you all these things in the my MATLAB. Set up all the x values so that x is a real number and then x is not equal to, you're going to write down all the numbers you found after solving for x. We call it set builder notation. Any question? You don't. No. Whatever you on the top, just ignore. It could be number, it could be anything else, but for now, as long as it doesn't have any square root, it doesn't have any square root and inside you have an x, then you're fine. You don't have to worry about that. Square root with an x inside, then you have to worry about that. But it's not in this class, you're going to worry about that in your pre-calculus. So life is easy, guys. Okay, here. There will be nothing on the numerator that you have to worry about. Just have to look at the denominator and get the result. So try the next one. Next one is much easier than what we did this one. You're finding the domain. Find the domain of this rational expression. What is this? Ready? Okay, how do you start? Hamza, go ahead. Minus x. Cannot be 0. This is equal and not equal. It cannot be 0. Says, okay, 11 goes to the other side. And then
negative x divide negative.
so you are subtracting 11 from both sides. So you get negative x cannot be negative 11. And then divide by negative 1. So x cannot be positive 11. Parentheses, negative infinity to 11. Parentheses, union.
And 11 to
infinity. Perfect. So here you can do also another way, or we have 11 minus x cannot be 0. Add x to both sides. So x cannot be 11. It's simple. So x can be everything else, but it cannot be 11. That means from the number line, we have negative infinity to positive infinity. We can take every number besides the 11. So anything before 11, anything after 11, everything else except the 11. And that's how we find the domain of rational. So the Sec7.1 notation says our domain is all the x values, so that x is a real number, and then x cannot be what? 11. So this is for my method. My method will ask you to do this. But in the exam, I'm going to ask you this. Find the implementation. Any question? For rational, no bracket. Because all those numbers we have, we cannot use them. And when we cannot use anything, we represent that using a parenthesis. Do you remember learning this before? Does this ring any bell in your head? We actually learned it twice before in this class. Once in domain section and once somewhere. I forgot. Okay, so we did two things. We evaluated rational expression, we found the domain, and now we are going to simplify them. Simplifying is easy. All you have to do is factor and cancel. So factor, cancel, after cancellation, whatever remains, you rewrite. And you're allowed to cancel only when if you have a multiplication on the left side and on the right side of whatever you're trying to cancel. Okay? So, for example, if you have x plus 2 over, let's say x, okay, over x, we are allowed to cancel here because this x has nothing on the left and on the right is the multiplication. So as long as you have a multiplication on the left or on the right, then you can cancel. So you can cancel this with the denominator because of the multiplication. So you cancel and then you rewrite x plus 2. But if you have only x plus 2, and you are dividing by x, now can you cancel the top x to the bottom x? We cannot, because even though this x has nothing on the left, but it doesn't have multiplication on the right, it is a plus. As long as you don't have a multiplication for any other sign, it cannot divide. So for addition, subtraction, division sign, you cannot cancel. You can only cancel if you have multiplication on the left and multiplication on the right. So here we have multiplication on the left, 1 times x, invisible multiplication. Same thing here, it's 1 times x, invisible multiplication. So multiplication on the left and multiplication on the right. If you have that, only then you can cancel. Okay? So here cancellation is not possible. We cannot cancel them. Cannot cancel x. Okay? So as long as you remember this and you cannot cancel in addition and subtraction, then it's easy for you to simplify. First step, factor, either using GCF or any other method, whatever method you have. Factor, cancel whatever you can cancel, one from the numerator, one from the denominator. If you have many numerators and many denominators, it doesn't matter. As long as one thing is one of the numerator and another thing is one of the denominator and they're cancelable, you can cancel. And then whatever remains, you just rewrite. Rewrite on their proper position. Whatever remains to the top, you have to put down the top. Whatever remains to the denominator, you have to put down the denominator. You cannot switch them around. For example, here, the x plus 2 on the numerator, so it has to be on the numerator. We cannot do the denominator. Let's do an example. We have only one number on the top, 5. What can you do to the denominator? DCF. This is factorable. What can you factor out? Since you have 5 on the top, can you factor out at least 5 from the denominator? You can factor 15, but suppose you don't feel like you can factor out 15. Then based on the numerator, we need only 5 of them. So can you factor out only 5, at least 5? What remains then? 5 goes to 15x how many times? 3. And 5 goes to 75 how many times? 15. If you don't know that, I can show you the new division. We are dividing by 5. 5 goes to 7 how many times? Once. Then you multiply. 5 times 1 is 5. You put under 7 and then you subtract. We get 2 from the subtraction. It's time to bring down the next number, so it becomes 25. And now 5 goes to 25 how many times? 5 times. 5 times 25, 5 times 5 is 25. And we have no remainder, that means we are done. So we rewrite 5 on the top and then 5, 3x plus 15 on the bottom. Can you cancel 5 from the numerator and denominator? We can, because the denominator 5 has multiplication on the left side and multiplication on the right side. So you're allowed to cancel. And now what remains? 3x plus 15, definitely. But what is its position? On the denominator. Then what goes on the numerator, Eliza? What goes on the numerator? Huh? What's the multiplication?
No, 5 canceled out.
So 1 times 5, like the invisible 1. So you can see this. Anytime you have anything, it's 1 times that. So that's why I said 5 is a multiplication on the left, which is invisible, and we have a multiplication on the right, which is visible. Anytime you have anything single alone, they have a multiplication of sense. Since you have nothing left, that means you have 1. That's why the position is very important. We know the answer is 3x plus 15, but where is it? It's not a whole number, it's a fraction. So it's 1 over that. Question? Okay, let's see the next one. You have 2 of them. Copy them down, and then we're going to do them together.
Alright.
Yeah. How can you simplify? You can factor more, but not simplify more. You can factor out 3, then what remains? X plus 5.
So that will be accepted, right?
So this is factoring. You can factor more, but you don't have to because with that 3 we are not doing anything. That's why you can factor out 15 here instead of 5. If you factor out 15, you get this answer directly. But see, when you see 15 and 75, definitely 5 comes in the mind. 15 doesn't right away. Do I have more? Oh, I have more, so let me write it here. Oh, my pen is done. Okay, erase do that. Oh, let me pull my pen's battery out. Ready? Jasim, what do you see? What do you observe? For the first one, it says difference, right? But do you see any negative sign? So it's not difference. How about the numerator? You have 3x and 27. Can you factor anything? What can you factor? 27 doesn't have any x. How about the numbers? You have 3 and 27. Can you factor out anything? 3. Great. Once you factor the 3 out, what remains? 3 goes to 27 how many times? 3 times what is 27? 9. Okay. How about the denominator? You have x squared plus 9x. You can factor out x. What remains then?
X plus 9.
X plus 9. Perfect. And then what do you observe?
Yeah.
So what remains? 3 over x. Any questions from anyone?
There's something to worry about.
For domain.
Oh,
But here it is simplified. For simplified, you have to worry about everything. Only for domain. See, domain start with D, denominator start with D. So domain only looks for denominator, dt. Who would like to help me with C, the next one? Martin?
X.
If you have x squared minus y squared, what's the product? What's the factors? Ignore that, okay? I'm asking you a different question. Let's say you have x squared minus y squared. So what are the two factors we have? X plus y, x minus y. Let's say you have a squared minus b squared. What are the products you have, the factors? A plus b, a minus b. Now let's say you have p squared minus q squared. What are the two factors we have? P plus q, p minus q. Right? No question, right? These are true. What? Oh, my head is hurting. What do you observe in all the factors based on what is given?
Both are squared.
Both are square. And you have a minus between them, perfect. Anything else do you observe? From here, what do you observe here? You factored, all of these are correct. None of these are wrong, they're correct. But what do you observe? I have x squared minus y squared. So x plus y, x minus y. Which one comes first, x or the y? And where do you see x here, the first one or the second one? So what would be the factors here? 1 plus x, 1 minus x. The plus one doesn't matter. For addition, you can switch the position. But for minus, it does matter. 1 minus x is not same as x minus 1. So x minus y is not same as y minus x. So anytime you're using the public squares, whatever is the first term, the first base, you have to write them first. Especially for the minus one. But the plus one is okay. Now we have x minus 1 the bottom. Let me use this. So here I was showing you a square minus b square means a comes first, b comes later. B square minus q, p comes first, and then q. So anything is using difference of squares, the first base has to be written first. Now I need space, so let me erase all of these. And now what do you observe? We have 1 plus x, 1 minus x, and you're dividing by x minus 1. Can we cancel anything? Looks like we cannot, right? Because definitely x minus 1 is not same as 1 minus x. Now let me show you something different. Let's say you have 3 minus 2. What is 3 minus 2? 3 minus 2 is a number. What is 3 minus 2? 1. What is 2 minus 3? Negative 1. Let's say you have 5 minus 3. What is 5 minus 3? 2. What is 3 minus 5? Negative 2. So what do you observe? 3 minus 2 and 2 minus 3. What do they have? Same one, but the signs are different. So they're almost same. One is negative of the other one, right? 5 minus 3 is 2. 3 minus 5 is same 2, but just negative. So they're same, but are they exactly same? They're negative of one another. So yes, we are allowed to cancel them, no problem. But do you get 1 from the cancellation? Because they're not exactly 1. What's the relationship they have? One is, what is the other one? Negative of the other one. So we have a negative 1 left. Just like this one. 3 minus 2 is 1. 2 minus 3 is same 1, but negative. 5 minus 3 is 2. 3 minus 2 is 3 minus 5 is same 2, but just negative. So when you have the exact same two things, just position reverse. Yes, you can cancel them, but the result is 1. the result is not 1, it's negative 1. So 1 minus x and x minus 1, they're not exactly the same, they're negative of one another. So when we cancel, we get a negative 1 left. In other words, we have negative 1 times 1 plus x. Or negative 1 plus x. Or you can distribute the negative, negative 1 minus x. Any of the three answers are correct. The main idea here is cancellation. As long as you have the same two terms, you can cancel them with a negative 1.
So if it was 2 negative x and x negative 2, it would be negative 2. Yeah.
It's same thing, 1.
Negative 1.
Because you have x and 2, and you have x and 2. The same x and 2, right? Their position just reversed. So you have 1. Here, I'm showing you that it doesn't matter what number you take, you get the same answer, just they are negative of one another. So as long as you have the same two things, you can cancel them, you're left with negative 1.
But if it was 1 plus x and 1 plus 1.
Maybe it's plus. For addition, it doesn't matter. We can cancel anything. 1 plus x and x plus 1, we can cancel them. They're same. Because 1 plus 1 is 2. Same thing, if you reverse the position, 1 plus 1 is still 2. The same thing, same number.
So any negative number is always
Negative 1. If one of them, if they switch their position, if they reverse their position, so you can cancel with a negative 1. Okay, last one. Angel. The last one. So what do you observe on the numerator, Angel? What do you observe on the numerator? It's a cubic, but our goal is to simplify. So when you're simplifying, our goal is to observe is factorable. Can you factor anything? X to the second power. What remains? X plus 11. Kelly says, do you like to try the denominator?
I'm not sure.
So we did GCF here. And what you're going to do at the denominator? 3 terms. So we have many factoring methods, right? Which method you are going to use? Christopher. Direct factoring. Because we are not doing anything else besides factoring. So we're going to factoring directly. 11.3, good. 11 is what? Positive, because the middle sign is positive. Then 3 is what? Negative. So it's called direct factoring because from the given line, we are going to factor right away, directly, without doing anything else, directly. Okay. Crucial. What do you think our next step is? We can cancel x plus 11. Great. What remains then? X squared. X minus u on the numerator or on the denominator? Denominator. And that's it. That's all you have to do. Factor, cancel, rewrite. That's how we simplify. The hardest part is factoring. Think which way to factor. What's the method we have? What do we have? And which method we can use. So figuring out that is the hardest one. And once you factor, you can see what's cancelable. Exactly same way we do multiplication. But before going to multiplication, let me show you that negative. If you fraction as a negative, it means either the numerator is negative or the denominator is negative, not both of them. Okay, so negative doesn't mean if you have negative a, it doesn't mean negative a or negative b. Why it doesn't mean that? Because if you have double negative, it's positive, but you have a negative, so you cannot have two negatives. So when you have a negative only once, either the numerator is negative or the denominator is negative. You can put it anywhere based on your needs. Now this is from my method. It says write this into equivalent form. Equivalent form means write the same thing, but just place your negative in different position. So for example, this is same as negative on the top and denominator is same. Also, this is same as negative on the bottom and numerator is positive. Also, this is same as negative x over 5x minus 4. Also, this is 3 on the top and the denominator is, so you're distributing here, you're distributing here. So all 5 things, they are the same thing. I'm just written them in 5 different ways, but they represent the same thing. Okay, so you can negative, you can write many ways. So my method will ask you, write some equivalent form. All you have to do is play with the negative sign. That's it. Now, more elaboration on what we did before. X plus 2 plus x. If you don't know what to do, always replace x with 0 and see what happens. Okay? So let me write it down. If you don't know what to do, substitute x with 0 and simplify. You get the answer. Okay? So let's say you don't know, well, what is x plus 2 over 2 plus x? No problem. Let's say x is 0. Then we have 0 plus 2 over 2 plus 0, right? What is 0 plus 2? 2. And what is 2 plus? What is 2 divided by 2? 1. So the answer is 1. Okay. In other words, for addition, it doesn't matter if you switch the position. When you cancel the exact same things, they become 1. And the next one, let's say you forgot what I taught you before. That you have x plus x minus 2 and 2 minus x. You have no idea what's the answer, 1 or negative 1 or what. No problem. Do the same thing. Let's say x is 0. So you have 0 minus 2 over 2 minus 0. This is 0 minus 2. Negative 2. What is 2 minus 0? Positive 2. And if you divide negative 2 over positive 2, what's the answer? Negative 1, right? It's negative 2 over positive 2. So here, yes, you can cancel, but the answer is negative 1. That's why when you have the exact same two things, just their position reversed, yes, you can cancel them. The answer is negative 1. If the signs are different. If they're the exact same sign, then it's 1. Different sign, it's negative 1. And if you forget, just replace 0 and then cancel. Now let's say this is 4. Try this too. We have x minus 4 over 4 minus x. The next one is 9 minus y squared over y minus 3. I forgot to take that attendance. Today is 7/7. Liliana here, Martin here, Christopher here, Axel here, Betty is here, Eliza here, Angel here, Handa here, Maria here, Ashley here, Exona here, Jason here, Kathy here, Asim here, Kayla here, Michelle here, Calicius here, Mariam here, Kay here, Chanel here, Jasim here. Oh man, almost perfect attendance. Except John. John is not here. Later. Kayla, what do you have for A? We have x minus 4, you're dividing by 4 minus x. You're confused, no problem. When you're confused, what suggestion I give you? Substitute x with 0. So if you substitute x with 0, you have 0 minus 4 over 4 minus 0. And then what? What is 0 minus 4? Good. What is 4 minus 0? 4 minus 0. 1 or 4? What did you say? 4. Okay. And what is, if you divide, what do you get? So what's the answer here? See? Chanel. Nine what? So you have 9 minus y squared, and how do you factor that? But how do you rewrite 9? What square is 9? Remember, you're applying difference of perfect squares. So 9 is 3 square, right? So you are going to add and subtract the bases, not the entire thing. So what are the two factors we have? 3 plus y minus y. Perfect. And the denominator we have y minus 3. Good job. -1. So what's the final answer? 3 plus y. You can leave it here if you want. Or you can distribute the negative and you write -3 minus y. Both of them are correct. But good job, you got it. Any question from anyone? So see the position. Whatever it has the square first, we had to write that in the first position. So you have 3 square minus y square. So you have to write 3 first and then the y. I believe this is the last one here. Mariam.
You can different factor by group.
Good job. Grouping. Because you have 4 terms. So it doesn't matter how do you group, mostly it doesn't matter. So let's hear grouping 2 by 2. In the first two, what do you see in common? Y. What remains? Y minus x. And then the second group, how does the second group start? With a negative, right? Do you like negative? So you have to pull out the negative.
Then you divide it by 4.
So you factor out 4.
Then you get
Y minus x. And we still have the two groups.
like
Y minus x, y minus 4. And then we still have our denominator format this way. Any questions so far? Is there anybody who is lost what we did? So it goes back to the method I taught you. 4 terms means you have two choices, either GCF or grouping. Here, GCF is not possible because not all 4 of them have the same thing. So you go to the grouping. You group 2 by 2 and then you factor out individually. The second group starts with a negative sign, so you have to factor out negative. Anytime you start with a negative, factor that out. So in the second group, we have the same factor y minus x, you factor that out. Then for the first group, you have y, for the second group, you have -4, you put that to the right. This is called grouping method. But we still have a denominator. And now you observe the numerator and the denominator. Go ahead, Mariam. What happens then?
The same rule applies from the previous problem.
We can cancel y minus 4 and 4 minus y. But what do you get? Negative 1. What is our answer?
No,
Y minus x. And if you distribute the negative, it becomes
negative y plus x.
positive x, which is same as x minus y. So basically, you're left with x minus y. But all three things are same. So all of them are correct. Any question? So if you know how to simplify, that means you know how to multiply. Multiplying and simplifying, they're exact same thing. You factor, cancel, rewrite. The difference between multiplying and simplifying is that when you simplify, we only one fraction to work with, but in multiplication or division, we have two fractions to work with. So we are done with 7.1. Now we are going to 7.2. We are going to multiply. Let's start with something simple. 2/3 times 9/4. If you don't multiply across, what else we can do? Let's say I don't want to multiply 2 times 9. Cross cancellation. So we can divide 2 and 4. 2 goes to 4 how many times? Twice. And since 4 is the bigger one, our answer has to go on the denominator. Whichever is bigger, the answer goes next to that. How about 3 and 9? 3 goes to 9 how many times? Where do we write the 3? On the denominator or on the numerator? On the numerator, because 9 is bigger. The bigger number gets the result. 4 is big, so it gets the result 2. 9 is big, so it gets the result 3. So whatever is the bigger, the result goes to that number. I'm going to put a little bit space. So what is our final answer? Whatever what? What do you want the numerator? 3 and denominator? 2. So it's 3/2. So if you don't multiply across, you can always cross cancel. Not cross multiply, cross cancel. Same thing is for polynomial or rational expression. Can you cancel anything in this expression? We have x plus 3 over x minus 5, and you're multiplying x minus 1 over x plus 3. Can you cancel anything? We can cancel x plus 3 from here and here. As long as one of them is on the numerator and the other one is the denominator, we can always cancel. So what remains? Minus 1 on the numerator, x minus 5 on the denominator. And this is for multiplication. We actually don't multiply them. Even though it says multiplication, we never multiply them. We always factor, cancel, rewrite. Here we didn't have to factor because they are not factorable. But now we are going to do a few examples where you're going to do factoring fast, cancel, and then rewrite. So let's do that. Still simple ones. Write them down, and then you're going to do them. But how many simple we have? Okay, let's do 3 of them together, and then you are going to do 3 to maybe 3 or 6. Maxim, what can we cancel here? X, X, Y, Y. So
9 over
Y goes to Y squared how many times? So do you get 1 left or do you get Y left?
Y.
Y. Where, on the numerator or on the denominator? Denominator. So let me actually do it here so you can see. So what remains? 9 over Y times 3 over 2. In other words, what over what?
27 over
2Y. So this line is extra. You don't have to write this line. I wrote it so that I can show you what remains, whatever remains, we just put them on their proper position and multiply them. So you can simply put 9 minus 9 times 3, 27, and then Y and 2 gives us Y. Any question on this one? Okay, let's do one more. Liliana, what do you think you can cancel this time?
The
X and X squared. So what remains?
2.5.
But we're not done here. We have X squared and you cancel X. So what remains? After the cancellation, what remains? X. Where, on the top or on the bottom? Good. Anything else? Can you cancel? So we have, let me change the color. We have this X and we have X7.
Then 2 times 5. And then
But when you cancel, you have to write what remains. So you cancel the X with X to the 7. So what remains after the cancellation? So you have X on the top and you cancel X to the 7 on the bottom. From this cancellation, what remains? Only one X remains? Cancellation means you're dividing, right? Any division, how do you combine the powers? Good. So which exponent is bigger, the numerator or the denominator? So the result is supposed to go where? On the numerator or on the denominator? Good. So how many x's left? 6. So you have x to the 6 on the denominator. And now you have no more x to cancel, so you look at the numbers. By observing the numbers, can you cancel anything? Really? 2 goes to 10 how many times?
5.
5 times.
5 over 5 cancel.
And now you have 5 and 5, they cancel. So after all these cancellations, what do you see we did not cancel? We canceled the 2 with the 10. What remains after all these cancellations? We left with x to the 6th power, definitely. Where, on the top or on the bottom? And what remains on the top? Good. So this is a tricky one where everything else cancels out, and some of them even cancel twice. Who is lost? You can always cancel as long as One is in the numerator, one is in the denominator. You can cancel from left to the right, right to the left. The position doesn't matter. Which position matter is either on the top and either on the bottom. Because as long as they have the opposite position, you can cancel. You can do cross and then also up down.
And you could simplify later.
So you cancel everything, whatever you can cancel. And then whatever remains, that's the final step. Rewrite whatever remains on their proper position. Okay, one more. The factor is already done for you. All you have to do is cancel. See what you can cancel. And let me pick Excel to cancel. It's a rise. What can you cancel? X minus 5? X minus 3, 3 minus x. But then are they exactly same? So what remains then? 1, negative 1. Because they are not exactly same. Oh, let me do it black. Second. Let's see. What else you can cancel? Excel. So you have x minus 5, 3 of them, and you have x minus 5, 1 of them. Yes, it definitely can cancel, but what's the result for the cancellation? Good, not x squared. X minus 5, the entire thing squared. So x minus 5, which is squared. Because in division, so this is your base. In division, you subtract the power, so 3 minus 1 gives you 2 of them with the same base. So what remains then? Negative what? Negative and then only x minus 5 square. Can you distribute the negative now? You think yes. So what's the order of operation? PEMDAS, right? PEMDAS. Parenthesis first, then exponent, then multiplication. So without doing your parentheses and exponent, can you do the multiplication? So it's not distributable. It doesn't matter. You can put it on the denominator, you can put it in the numerator, anywhere that. Because it's always better to put in the numerator. So you have to write the negative on the denominator. You cannot put a negative on the denominator. Negative one. Any question? So how do you feel about cancellation? They're fun, right? Negative x minus 5 squared. They're fun, right? Really? Why not? Try this thing. Try them for, let's say 65. Try them for 5 minutes. And then we'll do them together. Once we're done with this, we're done with 7.2. And then division is the exact same thing as multiplication, only one thing different. So let's see. Division. Okay. After multiplication, we are going to do division. And then tomorrow we're going to do addition and subtraction. There are only 3 questions. Remember, factor, cancel, rewrite. These are the steps. Yeah, it's not here in the minus.
Just like the -1 plus
Because you have A plus B. So in one you're adding B, and another one is subtracting B. How do you finish the first?
you should have
Yes, you have both of them have opposite sides. But we only B has opposite sides, but here B plus C and remember, the rule for calculation is on the left and the right equal. These two has first side on the right side. The reverse calculation is expected first. So B and no, other than effective. What do they do?
being serious.
It's a factor. So observe all 4 of them. Which one you can factor? Start to the top right. So top left. Can you factor? Factor one. So keep and each one of them individually and see which one is factor. You cannot cancel, why not?
Yeah.
Because we have a plus. In order to cancel, we have to do multiplication on the left and the right. Let's see. So this part is okay. And here, also the minus we can allow one of them. Two. So, what happened to this thing?
Right here.
A to A, and then what do you observe?
And can.
See, A and A, obviously we can cancel them. And how about this one? It's 2A and 2B. What happened to your 2 here? It's 2A plus 2B, right?
Ooh.
So they start with something wrong. These 2A's, which side on the right?
A squared. Was
These 2A's, which side on the right? 22 side. Can you cancel one in your class? You have to cancel that, right, to the classification. Cannot. There's three equals to. Look, I said factor first. Is this factorable? Is this factorable? You have the same problem. You cannot cancel the student A because it's 2A. That's a multiplication device. It has an additional device. And if you have an addition, subtraction, and division, anything else, you can multiply. So you have two factors. Yeah. Okay. The sciences? How about the science? So we have 9 and 4. One of them has to be 9 and 4. Then 4 has to be plus or minus.
Oh, okay.
You want to be going on? Okay, can you cancel in the plus or minus? You have to cancel what lecture, what side, what to that. Multiplication. Even you need a recipe. We started canceling. You two have a multiplication. Real, if 2A plus 2B. Yeah. But what about the A? I didn't use it. You cancel. I mean, you cancel too. No, but because this year the multiplication and we combine together just A times C and this. But then you have to divide the two by combine that enters out of you. This change you can because there's no calculation what you use with the and this within our or is it now one you want to what is mentioned but it's not
I got you.
because you would be happy with it.
Well, it's here.
Two terms. What are the
Right? I think I'm wrong.
what you have?
I think you're wrong.
Oh, yeah.
But the thing is, that it's like an 8, 6, and then 6, and 8 is 6. Wait, like that, where that 8 comes from? Yeah.
And what's
We're
your
factoring.
Well, because we can't cancel out each other, right?
No, if you're exact difference.
They can't. So, plus 7 and plus 7 cancel. Okay, okay. I got it. I'm surprised.
Here, I
I don't know.
have the same fraction, but in a fraction, right? Factor is minus 4.
Yeah, if I can look at like these, to like if one.
Then here, x factor
What are those?
No, both of them. Here. Ah, okay.
there, right?
So you cannot verify it.
That's
Right, now, no, wait, I did do that. Yeah, that's what. Yeah. Oh, I just asked them for the answer. That's what the answer.
So
Yeah,
would
that's
that
what
be
they-
right, or would it just be
Yeah.
so then everything goes.
It's so annoying. I'm bringing that back.
Then you have to, then you have left with your left. Yes.
Which one has what you do?
Oh.
Why did you do that?
Last name. Why name is?
Yeah.
Okay.
So you got.
That's right. So.
So it's not a way. So you have these over there. Then how do you minus one? These are minus because they are not opposite of one another. Here, he, only B changed the sign, but A still has the same sign.
Not down there.
A minus B and B minus A just but A minus B and A plus B they are not opposite.
I'm sure you know that.
So you can cancel it.
That your notes on the sports and I'll be.
You have to read this cancel.
So when you're not
using
Yes.
so as long as both of them have their signs, then you can. And the positive sign, you're not doing anything right.
Yeah.
We have 4 of them, and so with one of them.
Yes.
Okay, let's do it together. So I realized the first one was the hardest one for all of you, almost all of you. Well, actually, it's the easiest one. 2 terms means GCF, right? GCF or difference of half squares. Always start with GCF, always, okay? If GCF doesn't work, then see if other methods work. So we have A square minus AB. They both have A in them, A and A, so it's GCF. We factor out A and we get A minus B. And we have 2A. On the second one, we have 2 as GCF. This is 2, this is 2. They both have 2 in them. So you factor out 2 and we get A plus B. The denominator, we have nothing to do, so we leave off what power L. So factoring is done. Now the fun part, cancellation. A is in the numerator, A is in the denominator. As long as 1 is in the numerator, 1 is in the denominator, you can always cancel. We can cancel these 2 with these 2 because that 2 has a times A plus B. So it's a multiplication. Now we have A minus B, 1 of them here, A minus B, 4 of them here. So how many left? On the top or on the bottom? On the bottom. A minus B, 3 of them. So from the left fraction, we canceled everything. From the right one, we left 2 with A plus B and A minus B cubed. And then I noticed the common mistake. It is canceled and said, oh, it's -1. We can only cancel if we have both signs opposite. So if you have A minus B, you have to have a B minus A. See, B is negative here, it's positive here. A is positive here, A is negative here. If you have this pair, they both are same thing with opposite sign, both of them, then the answer is -1. But here, only B has opposite sign. A still has the same sign, so you cannot cancel. A is positive on the top, A is positive on the bottom. How can you cancel? And then these are just fun ones. All you have to do is factor, 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 and then cancel. So let's start to the top. Left. Who wants to try the top left? This one.
X plus 4, X plus 6, X plus 4.
X plus 6, X plus 4. Kelly's, yes. Bottom.
X plus 6 and X plus 7.
X plus 6, X plus 7. Christopher, top right. The 2 terms means GCF. So GCF or perfect square. Here perfect square doesn't make sense, so GCF. Matthews, the bottom right. Multiply to -36 combine to 5. Two numbers multiply to 36 combine to 5. 2 times 3 is not 36.
Hold on, I'm just lost. Okay.
Okay, no problem. Ashley. X plus 4, X minus 9. Okay, no problem. So we factored everything, and then it's time to cancel. Exona. What can you cancel?
X plus 6.
What else? See X plus 4 on the top and X plus 4 on the bottom. Anything else?
Oh, X plus 7.
X plus 7, X plus 7. X over X minus 9. That's it. And these are final exam question. One of them for the multiplication or division definitely comes in the final exam. The next one is the same thing. The only difference is here. These 2 terms, how you're going to factor? X plus 4, X minus 4. So this is difference of perfect squares. The previous one, GCF, this one is difference of perfect squares. Okay, K, what do we have here? Two numbers multiplied to 28 combined to 3. When you see 28, which two numbers comes in your mind? 7 and 4. So what sign 7 has to have? It's the bigger one. Bigger one always gets which sign? The middle sign. Whatever sign is in the middle, the bigger factor always gets that sign. So 7 has to be minus. Now from 7, if you want to get 3, how you're going to work with 4? Are you going to add 4 or subtract 4? Add. Great. Now we are going to the left. Liliana, the top left. Multiply to 35 combined to 2.
7 and 5
7 and 5. Now decide their signs.
plus 7 negative 5.
Which sign, middle sign? The middle term has which sign?
Oh, negative 7 positive 5.
Negative 7, positive 5. Matthews, are you okay now for 15? Two numbers multiplied to 15 combined to 8.
3 and 5.
3 and 5. Decide their sign. Positive. Perfect. Now, who would like to cancel? Maria. X minus 7, X minus 7.
And then X plus 5.
On the top we have X plus 5. X plus 5, X plus 5.
And then
X plus 4, X plus 4.
and then you're left with X minus 4.
X minus 4 over X plus 3. Now, do you guys like it? Still don't like it? Well, we know how to multiply. That means we know how to divide. Division is multiplication, but there is only one difference. We don't know how to divide, right? So instead of dividing, what do? We multiply by reciprocal. So that's all we have to do. First, we are going to factor, and then we're going to multiply by the reciprocal, and then we do cancellation, rewrite. So let's go do that. This. We don't know how to divide. Instead, we multiply by the reciprocal. So, steps. Factor. Keep, change, flip. So, KCF. These two are interchangeable. Either you do keep, change, flip first and then factor, or you can factor first and do keep, change, flip. But I will suggest do factoring first. And then we do cancel and then rewrite. So keep, change, flip. So we are going to keep the left fraction, change the division into multiplication, and we are going to flip the right fraction. That's how we divide. We don't know how to divide, we multiply with the reciprocal. So we are going to multiply with the reciprocal. Reciprocal means you just flip top and bottom. That's it. So here we didn't have to do factoring because that's factorable. So we keep 6x to the 8 over y squared. We change the division sign into multiplication sign, and then we flip means we are using the reciprocal. So 3, 2, x to the 8, y squared. Keep, change, flip. So KCF. And then we cancel just like before. We have x to the 8, x to the 8. We have 2 and we have 6. 2 goes to 6 3 times. Can you cancel these 3 with these 3? No, because they're on the same side. If they're on the same side, we cannot cancel. Can you cancel the y square with the y square? No. That means we have nothing else to cancel. So we multiply 3 and 3, we get 9. And we multiply y squared with y squared. Good, y to the 4. So let me show you what I multiplied. I multiplied 3 with this 3, this y square with this y square. 3 times 3, 9, y square times y square. In multiplication, we add the powers, so it's y to the 4. Any question? That means we are done with the left. Now we are going to the right. We are going to do future later after multiplication, after
So
factoring.
you just went backwards. So that's x minus 5, x plus 5. And the second, like the denominator is.
X plus 5, x minus 5. And how about the denominator?
Is x minus 3, x plus 2.
X minus 3, x plus 2.
And for the other side, UGCF.
So both of them are GCF. Perfect. So what can you factor out?
For the numerator, the x squared, for the denominator.
So from x squared, what left?
X plus 5.
X minus 3. So we used difference of perfect square for the top left. For the right side, it's both of them GCF, and the denominator on the left is direct factoring. So we did factoring, and now we are going to keep the left fraction, change this division sign into multiplication, and flip the right fraction. So we have x plus 5, x minus 5, x minus 3, x plus 2. The division sign suddenly changed into multiplication sign, and we flip the right side. X cubed, x minus 3, x squared, x plus 5. And now the fun part. Who would like to do the fun part? Eliza? Okay. X plus 5, x plus 5. X minus 3, x minus 3. X to the third and x to the second. In this cancellation, what is left? On the top or on the bottom? On the top. In division, we subtract the power. So 3 power minus 2 power is 1 power. So at the end, what is left? So we have this and this, right? So x minus 5. And what is left on the denominator? It's plus 2. That's it. Denominator has only one term, numerator has two terms, just put them together. Yes, you can distribute, but you don't have to. You can simply just put them together. With this, we are done with 5.2. I have more examples, 2 more examples. So what time is it? 47? We are fine. We are going to start with these 2 examples in our tomorrow, and then we are going to do addition and subtraction. Addition and subtraction is a little bit different than multiplication and division. So if you don't understand anything, make sure you ask your PLT leader on Wednesday. Okay? Addition and subtraction will be in the exam. It's a little bit difficult than multiplication. So Wednesday, don't miss your PLT. Go over the questions you don't understand from addition and subtraction, because you'll see them on passing in your exam. So, good night, everyone. See you tomorrow. How are you?
I wasn't here the past 2 weeks.